Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2, delayed from yesterday, for this week. And we're going to be taking a look at the gases that make up our atmosphere, the percentages of those gases, and the ones which are most dominant and which are exist in small concentrations, and then the radiative properties of those gases, and how by modifying the concentrations of some of those gases that the climate can be modified by doing that, okay? And again, as I mentioned at the end of the daily weather update, this will be purely from a science perspective, no politics here at all, either right or left or in the middle, all right? So let's go on ahead here and take a look. I've only got a couple of graphics to show you here today. But this is the makeup of the Earth's atmosphere. This has been known for a long time. Nitrogen, the dominant gas, at 78%. Oxygen at 21%. Then there's a gas called argon that makes up 0.93%, which only leaves 0.07% of the atmosphere to be made up by various what we call trace gases. And one of those trace gases is called carbon dioxide, and it makes up 0.04% of the Earth's atmosphere. Now, I'm sure you've heard the argument, how can anything that exists in that small of a concentration possibly affect the climate of the Earth? Well, we will talk about exactly how it can do that in just a second. Now, were it not for the natural amount of greenhouse gases, such as water vapor, which by the way is a greenhouse gas, carbon dioxide, methane, and nitrous oxide, the Earth's mean temperature, the average temperature, would be 60 degrees Fahrenheit colder, and the planet would be an uninhabitable ice ball. So you talk about a small amount of something being the difference between life and death, this is it, okay? And so the natural amount of carbon dioxide and other greenhouse gases are the reason we're here, and they are not inherently bad gases. Carbon dioxide is not evil in of itself. It contributes to life, okay? We wouldn't be here without it and the other various greenhouse gases, okay? So keep that in mind as a backdrop. Now, what I want to show you, and I know this may look a little confusing, but we'll try to sort this out here. These are wavelengths here, 1, 2, 3, all the way up to 30, and these are in units called microns, which are 10 to the minus 6th meters, okay? So you move the decimal point 6 to the left, okay, to get to what's called a micron. Now, the Earth emits infrared radiation, okay, at various wavelengths. And here you see water vapor up here, and this is absorption going from 0% to 100%. So in here, from about maybe 5 to 8 microns, water vapor absorbs virtually everything that's coming from the Earth and sends it back down to the Earth, okay? But the Earth does not radiate so much at those wavelengths, okay? So it's sort of irrelevant. In here, you see this big dip around 10 microns, and water vapor, this is called the water vapor window, and this is how we actually lose heat to space at night when the sun goes down, that infrared radiation being radiated by the Earth is able to escape to space without any interruption. But as you get up toward a wavelength closer to 15 microns, then this small amount of carbon dioxide, this 0.04%, is completely opaque to outgoing infrared radiation. Infrared radiation trying to leave the Earth and trying to leave the Earth's atmosphere at that wavelength, it ain't going to get out, okay? It's going to be completely blocked by that amount of CO2 at that particular wavelength, okay? So what happens then is that we know that carbon dioxide is the most effective gas at absorbing infrared radiation emitted by the Earth. And so it absorbs that radiation and then re-radiates it about half to space and half back down to the Earth. So it doesn't send all of it back down to the Earth, only about 50% of it, okay? So increasing the concentration of carbon dioxide is obviously going to increase that effect. That is not rocket science, okay? That's simply scientific logic, all right? And then as the atmosphere warms, its capacity to hold greater amounts of water vapor, okay, the warmer the air, the more water vapor it can hold. In fact, we've talked about this before, where a 50% relative humidity at 90 compared to a 50% relative humidity at 30 degrees, there's 8 times as much water vapor in the air at 90 than there is at 30, even though the relative humidity is 50%. So as you increase the temperature of the atmosphere, it can hold more water vapor. Water vapor is a greenhouse gas. That then sends more radiation back down to the Earth, and the two work in tandem, okay? And it just keeps getting warmer and warmer and warmer. So this wavelength interval right in here is the problem, okay? Now, there was a time, and I'm embarrassed to admit this, that I allowed my political ideology to dictate my opinion about climate change, and I'm embarrassed to admit that, but it's long in the distant past for me now, and I go purely with science, okay? And you may not know this, but there was a scientist back in the late 1800s that actually computed by pencil and paper, no computer models back then, right? Computed by pencil and paper that doubling the amount of CO2 in the Earth's atmosphere would result in so much warming over a period of time. And those calculations that he did by hand back then are all coming true, okay? So you can't blame this purely on a bunch of computer models that somebody claims are inaccurate, okay? Basically, this is something that's been known since the late 1800s, okay? So it's established science, okay? Now, the problem here, and it's become a big problem in recent years, is the fact that, and by the way, I need to be honest here, I have problems with both the right and the left on how they're handling this. You cannot go from the burning of fossil fuels to green energy overnight. It can't be done. Solar and wind is not going to do it, at least not with the knowledge and abilities that we have right now. So we need a transition to get from the burning of fossil fuels to where we want to go down the road. And the best option in that arena is nuclear power. And there are some people, in fact, a lot of people, that are ardently against that, based mostly on the fact that, yes, there were some accidents many, many, many years ago, but the technology has increased immensely since that point in time. And nuclear power does afford us the greatest chance to make that transition from the burning of fossil fuels to where we want to go way on down the road, okay? So again, there are hindrances on both sides here that are getting in the way of progress, and this issue that we're talking about here is the best science we have. Now, with any scientific prediction, there is always uncertainty, okay? And the best estimates right now is that the Earth's atmosphere would warm anywhere from 2 to 9 degrees Fahrenheit over the next 100 years. Now, that's a big range, okay? 2 degrees Fahrenheit, we can probably adapt to that without much problem, okay? If it's 5, there probably will be some serious issues, but in the end, we can figure out a way out of it. If it's 9, then we're talking about the potential for a catastrophic change in climate, okay? And there are such things as low probability, high impact events, where you may not think the chance of it happening is all that high, but if it does, there is no going back. There is no recovery, okay? It's out of your control at that point in time. So the goal here, in my mind and many other people's minds, is to figure out a way to minimize the risk without doing undue harm to people, okay? And I think if we remember that we're all Americans first and that we're all in this together, then we can come together and talk about this and figure out a way to minimize that risk without doing undue harm to anybody, okay? I think that can be done. It's just that we live in an age right now where it's very difficult sometimes to get people to talk to each other and to compromise. In other words, if you're not on my team, I want nothing to do with you. You know, I know of friendships, you probably do too, that have been severed by the fact that people have that much of a disagreement in the political arena, which is just stupid. It really, really is. So anyways, this is the science, okay? There's no getting around the gases that make up our atmosphere and what the absorption and emission properties are of those gases. We know what they do. The question is, how much of an effect is it going to have on us? So let's work together, figure out a way to minimize that risk, and then I think we can actually all be happy at some point. I don't see it now, but I'm hopeful that will happen sometime in the near future. All right, folks, that's it for now. And that is bonus weather video number 2 for this week. Number 3 coming up tomorrow. Next daily weather update coming up tomorrow as well. You all take care, folks. Have a great Thursday evening. We'll talk to you soon. See you later.